Cool. Thanks, everyone. Welcome to my 8th Light U talk today, Managing Dependencies in a Front-End Design System. I'm going to be talking a lot about the front end, but also about design systems in general and fun things like monorepos. So thanks for joining my talk today. I'm Jen, like I said, I'm a software crafter at 8th Light. I've been developing on the front end, like Nicole said, since 2016, all the way back when I went to a coding bootcamp. I like working with React component libraries. I do it a lot. I've worked in React on every single project I've been on at 8th Light, and I really enjoy it. Oh boy, so front-end development, there's a lot going on here. A lot's changed since 2016. When I started developing on the front end, I was using vanilla JavaScript and jQuery. And React, my gosh, we started out using class components. Now everything is functional and there's hooks. That stuff didn't exist back then. But there's a number of tools that you can use on the front end to develop apps. And some of them are here, as you can see: React, Angular, Vue, Sass, JavaScript, TypeScript, HTML, CSS. All right, so I'm going to be talking about a specific stack today that I used on a previous client project that I worked on. It wrapped up just last month. But I really enjoyed working on this project. Me and Brian Sung, who is another 8th Light crafter who's giving a talk in January, were the two 8th Lights on this project. And we really tried to own the front end. So it was our job to sort of make sense of what was going on in the code base. The stack that we were working with was React with TypeScript. We also created a Storybook library, and we used Yarn and Learna to manage packages. All right, so on the front end, like I said, a lot has changed, but component libraries are pretty much here to stay. If you're a front-end developer yourself, you're probably no stranger to component libraries. You probably work with them every day or have seen a lot of them. Some of them are cool, some of them are nightmares, but for the most part, if you're using React and Storybook, it's probably a good idea. So let's see. Component libraries, what can I say? This is a normal component library in any app. This is just an example. You'll see like a top-level components folder. And then your components live in here. So I've just highlighted one component that was in our actual app, a modal. And you can see there is the modal file itself, there's the SCSS file, and a test file where we put all of our unit tests. And so pretty much every component in the app looked like this. But this was sort of a tricky code base, like I said, and we'll get into more of that later. All right, so the problem. Myself and Brian Sung were tasked with building out a component library for the client, and I'm going to refer to the client as client X just to maintain privacy during this talk. This client was a Series D startup whose clients included major retailers and brands, and they were scaling very rapidly. Client X had several existing apps that each contained their own component libraries. They were at the point where they realized that maintaining several component libraries was becoming unscalable, and they wanted to standardize their components. So what was the solution to this? We decided to set up a Storybook library for them. And Storybook is a design system that consolidates common UI components in a central, well-maintained repository that gets distributed via a package manager. If you haven't worked with Storybook before on the front end, I highly recommend it. It's great not only for devs and designers, but to any stakeholders that are looking at your project and want to see progress. It gives you a neat little storybook to show them in the browser of all your components. And they can play with it, they can change different things and see different variations of a button, for example, or a modal or a menu. And it just makes everything really nice to look at. Do you need a design system? So this is a great question. You should ask yourself this question before starting any project. A design system is not a silver bullet. If you're working in a single app, then you're probably better off with a directory of UI components instead of setting up the infrastructure needed for a design system. For small projects, the cost of maintenance, integration, and tooling far outweighs any productivity benefits that you might get from setting up a design system. However, design systems are great for sharing UI components among multiple apps, which was the problem that we were trying to solve on this client project. All right, here is a diagram of the Storybook design system, and this was taken directly from their website. You can go read the Storybook docs to find more information about it. But this, in a nutshell, is what a design system is at the most basic level. So you've got your design system. It exists in a single repo, and it's meant to be shared across multiple apps in the organization. So here are 3 examples. You've got a web app, and you've got a marketing site, and you also have a doc site. But you want all 3 of those apps to use a single component library. And so you're going to be setting up a design system filled with components to use across all of these different apps. Okay. All right, so one thing about a design system is that it must be independent of any project and also a dependency of all projects. Changes propagate throughout the organization via a version package distributed by a package manager. And we'll get into package managers a little bit more soon. Projects can reuse design system components and further customize it if needed, as we saw on the previous slide. And this pretty much makes sense. You can build a design system, which is essentially a component library that lives outside of the rest of your apps. And then you can import them into the apps wherever they're needed. This should be simple, but you might run into some issues later involving dependencies that we're going to get into today. All right, Client X's design system. On the left here is a diagram of the atomic design system. And if you're not familiar with atomic design, I recommend that you check out Atomic Design by Brad Frost. It's free on the internet. He has a blog. He has a lot of resources. And I'll just give you a quick rundown for those of you who aren't familiar with atomic design. This is actually the first project I've used atomic design on, but plenty of front-end devs and designers really enjoy it. And I can kind of see why it's sort of forward-thinking compared to what we're used to thinking about web pages, the frameworks that we used to think about web pages in the past. So just a TLDR, the philosophy is really about moving away from thinking of components and web pages as pages, which comes from the print world. And we're still referring to web pages as pages today, and move more towards thinking about components as sort of living organisms that are evolving over time. And so if you get into Atomic Design by Brad Frost, you'll be reading a lot of sciencey type of lingo because it draws heavily from, science principles and chemistry, that sort of thing. But, anything pertaining to a living organism. And so in this diagram, you can see there are atoms, there are molecules, there are organisms, there are templates, and there are pages. So really, the first 3 things are the most important. Templates and pages are created out of these essential building blocks. Atoms at the most basic level are really just, the most basic you can get in a component. For instance, like an input field, just by itself without anything else would be considered an atom. A molecule would be that same input field with a label or additional text, a heading or something like that. Molecules are really a combination of different types of atoms. And so you can see how we're sort of using these components as building blocks to create larger ecosystems. And then finally, we have organisms, which could be a mixture of molecules and atoms, or just molecules or just atoms. And a good example of an organism is a header on a web page, because there's a lot of things going on. It could include a search bar, it could include menus with links. So you're going to be using a lot of the same building blocks, the same basic components in those organisms. On the right-hand side is our Storybook library that we built out for the clients. They called it their elemental design system, and I think they were using elemental because they were drawing from atomic design principles. And in the screenshot, you can see we've set up icons as atoms in the component library. And so each of these icons is considered an atom, and they get imported into molecules and into organisms to be used wherever they need to be used, such as in a button, in a larger component too. Okay, here's more of the client's design system. On the left-hand side, you can see an example of a molecule, which was the tabs molecule. And this is a combination of not only tabs, which are clickable links, but also you see there's like a thumbs up icon there, which was taken from the icon atoms that we just saw. So it's a mixture of different things here. And then on the right-hand side, we've got an example of an organism from the client Storybook, and that's a modal. And so there's several different things going on here. We've got like labels, headings, text, we've got buttons. So it's really a combination of different atoms and molecules here. Oops. Okay, so if you haven't worked with Storybook before, or even if you have, this is a nice refresher. What makes all this pretty stuff happen in the browser and the UI for people to play with is this stories file. So you can see on the left-hand side in the directory tree, there's this button stories.tsx file, and you can see it's got all the different stories for the buttons. There's a primary button, a secondary button, a danger button, a tertiary button, an outline, excuse me. And all of these different things are what display in the browser in the Storybook library to people. So you can read more about this in the Storybook docs. Like I said, it's pretty simple to set up. And there are things like knobs and other stuff that we won't get into today, but it's pretty cool if you want to check that out. It just gives you more control over the UI. All right, so monorepos. You're like, Jen, I thought this talk was about dependencies. When are you going to talk about dependencies? Well, I can't talk about dependencies yet. I have to talk about monorepos first. So let's get into it. What is a monorepo? So the monorepo approach uses a single repository to host all the code for multiple libraries or services composing a company's application. So this is basically a long-winded way of saying that all the code lives in a single repository. We saw an example where in one of the earlier slides in the client's app, the front-end components lived in the same location as all of the back-end code. Everything was contained in the same repo. So that's essentially what a monorepo is at its most basic definition. The alternative to a monorepo is a polyrepo or a multi-repo, where the code lives in multiple repos. And you're probably more used to seeing this. It seems like a lot of developers on a lot of projects prefer to separate the code out between front end and back end. There are very good reasons for that. There are also very good reasons for using a monorepo. Some people really don't like monorepos, which we'll talk about later. But also some heavy hitters use monorepos, including Google, Facebook, Twitter, and other large tech organizations. All right, Babel also uses a monorepo. And this was taken from their GitHub, and I'll just read the top line, which says, juggling a multi-module project over multiple repos is like trying to teach a newborn baby how to ride a bike. And I've included a image here for you of a baby trying to ride a bike. I don't know how successful they are with that. You can decide for yourself if this is an app description or not, or if the metaphor could use a little bit more work. If you have used a monorepo before, let me know what you think about that description. But here's some pros and cons that they list out for using monorepos. Pros include, single lint build, test, and release process. easy to coordinate changes across modules, a single place to report issues, easier to set up a development environment, and tests across modules are run together, which finds bugs that touch multiple modules more easily. So those all sound like good things. What are the cons? The cons are that the code base looks more intimidating, the repo is bigger in size, you can't npm install modules directly from GitHub, which are serious concerns actually, and we'll get into more of that soon. Okay, as I said, some people really don't like monorepos. I pulled this Twitter post from a blog, I think, and this guy named Matt Klein, who is a software engineer at Lyft, posted this, and I'll just let you read it, but he thinks that monorepos are ridiculous. He also thinks that, I don't know, people who enjoy Rust and people who enjoy monorepos are of the same archetype, I guess. Make of that what you will. I am not here to judge your like or dislike of either monorepos or Rust, but just know that this is a thing. You can add him if you want to. All right, so we've talked about what a monorepo is essentially. And now let's talk about Learna. So I mentioned that we used Yarn and Learna to manage our packages on the client project. And let's see, maybe I should explain Learna first to you. Learna is a tool that optimizes the workflow around managing multi-package repositories. So this is important. Learna includes in its definition of a monorepo the ability to export multiple packages from a single repo. And that's sort of what we went with because we're using Learna on this project. That's how we ended up setting up the component library. Yarn, I'm sure if you guys are front-end developers, you are well aware of. It's a package manager for front-end modules. It's similar to NPM. And most people use Yarn and Learna together. You can Google, there's tons of blogs and resources on the internet about using Yarn and Learna. All right, so here are a few neat Learna commands that you can use in your project. Yarn Learna link is probably the most important one that you're going to use. And that symlinks all your dependencies, so you don't have to worry about one component being out of sync with another one. It will just do that for you. Another one is Yarn Learna Bootstrap, Yarn Learna Run Build, Yarn Storybook. That's just for running the Storybook library. And yeah, you can go to the Learna docs to read more about commands you can use in relation to Learna. Yarn Run New Package was one we used a lot to easily create new packages, AKA like spit out component files for us quickly. It's sort of like auto generates a bunch of component files that you need to create a brand new component. So that was really nice that we were able to use that. All right, who uses Learna? Like I said, lots of people, Babel, Facebook, React. There's a whole list of stuff on their website. And then here's a little description about Learna. And I'm just going to reiterate, it optimizes the workflow around managing multi-package repositories with Git and NPM. All right, finally, let's talk about dependencies. We're here. They're kind of a headache. Everyone knows about that. Yeah, what more do we need to know about dependencies besides NPM, right? Well, actually, if you're using Learna, there's quite a lot. And I didn't realize until I was working on this client project how much you have to consider when you're exporting multiple packages from a single repo. All right, so here's what the code ended up looking like. You'll see here that each component has its own package.json file, its own node module, and its own config file. And I put this grimacing face on the side because I had never seen anything like this before in a code base, and it was a lot of duplicated code. It was a lot of node modules. It was a lot of package.jsons, and I kind of had a freak out moment like, wow, there's so much in here. The code base is like exponentially larger now, which is a real concern. But more on that in a second. We also used rollup in our project. Let's see, do I have a good, this is basically, excuse me, notes, so that I can describe rollup accurately. Rollup is a module bundler for JavaScript, which compiles small pieces of code into something larger and more complex, such as a library or application. So you can use rollup in your apps, such as like we did here. But one thing you need to remember about using rollup is that you have to include your dependencies in the config file for every component. So here's an example of it. We're using an elemental checkbox in a table component here, which is an organism in our atomic design component library. And so we need to add it to the rollup config file at the bottom here in external dependencies. So we've got React, React DOM, and then we've got our elemental checkbox here. So what we had to do was manually add this to every rollup file. And there were some issues around us like forgetting to do it and then realizing, you know, when it wouldn't build that we needed to come in here and add it to the config. All right, so like I said, there's a whole lot going on here. There's a lot of package.json files, but don't worry, yarn Learna link, like I said, is the only command you really need to know about. It symlinks all your dependencies for you, and it makes sure that everything is up to date in your Monorepo. All right, so what did our dependencies look like in the main app? So here's our front-end facing app that we started to import our Storybook components into. And this is just your normal run-of-the-mill package.json file that you would see in any app. Under dependencies here, there's a lot of stuff, but the important part is all of these like components, elemental atoms here. You've got a button group, you got checkbox, chip, switch. So all of these things came from our elemental design system. And these were components that were exported as separate packages that we've imported into our main front-end app, and we're going to use in whatever component file needs to consume them. All right. So we had a number of pros, cons, and considerations for using monorepos, which I will get into here. The pros, so the great things about using monorepos are that you can export multiple packages from a monorepo and easily share packages across your apps, which is, I think, why the client decided to go this route and why they were really pushing for this Storybook with Learna implementation so that they could export various packages easily and use them throughout the organization. Another benefit is that your monorepo is a single source of component truth. You don't have random components in various apps like they had before we implemented this monorepo. And I don't have screenshots of their component directories, but it was wild. There were several different component directories like in a single app. There was lots of duplication. There were differing styles and approaches there. So like using a monorepo really streamlines all of that for you. And it reduces duplication because you know that, if you're using a checkbox that came from your design system and that was created and approved by designers, you set it up in your monorepo and you've exported it as a package. And so that's the one that you're going to be using in your app. Another benefit is that you can version control your components, which is like kind of a novel idea, or at least it was to me. I wasn't used to like having different versions of components before, because I've usually worked on projects that are a single app, and you only have one component library and you only need one type of component. You update it whenever it's needed, and you're done. But this kind of allows you to track progress over time and iterate on your components. in a really neat way. So you can go back and look at different versions of it. You can export the packages. Other people can track your progress over time throughout the organization. Yeah, and like I said, you can keep track of updates and iterations through different versions. Not only the devs, but like other stakeholders can see your progress over time. Oops, excuse me. Oh, okay. Cons. This is a sad face part. There's a lot more repeated code in your Monorepo now, and that tends to freak people out. There's a lot more in the code base. People aren't used to seeing that in a component library. It can be complicated depending on how complex your components are. You'll also have to keep track of your Monorepo package releases and make sure that your packages are up to date in your apps. So on our client project, this was actually a pain point for Brian Sung and myself. New releases had to be scheduled whenever a component was updated. So we couldn't just, a designer was like, we changed the design of this component. We want you to add these 3 things. We couldn't just go into the component and make those changes and voila, it pops up on the front end. Everybody's happy. The users see it, stakeholders see it. It didn't work that way. So, when you're exporting components as separate packages, you have to schedule releases for those packages. And this dramatically slowed down our development time. We really didn't build it into the initial scope of the project, but it's a consideration that, you need to be aware of if you're going to go this route. We also ran into this hiccup where there were multiple versions of the same package being used in the app, and like styles were overriding each other. We spent a lot of time debugging here, and I won't get into the nitty-gritty of it, but it was pretty much a pain. This is another thing to be aware of when you're releasing multiple packages and versions of those packages. All right, considerations. So exporting each component as a separate package is not done a lot, or not from what I've seen, because I haven't been used to it developing on the front end for several years now, except for in larger design systems. And there are some trade-offs that we've already noted. Storybook itself, funnily enough, acknowledges that some systems deliver each component as a separate package and others ship all components in one package. If you go to the Storybook docs, they actually recommend that you ship all the components in a single package. So this diagram that I have on the right-hand side is straight from the Storybook docs. It shows you that your entire design system gets shipped as a single package, and then you can iterate on that over time. There's different versions of that whole library. That is not what we did on this project. It would have drastically simplified things for us, but we decided to go a different route. For nascent design systems, they recommend publishing a single version package, like I said, that encapsulates the entire system. So what did we learn, or what did I learn from working on this client project with multi-package monorepos? There were a lot of great insights I took from working on this project, mainly around time estimation, about like the scope, the project scope, and lots of things were a headache and, took a lot longer than we anticipated, but it's just good knowledge to have. And if you ever find yourself in a situation where you're considering doing this using a multi-package monorepo, it's just good to be aware of these things so that you can kind of gauge for yourself, like how much time investment is needed here. And then you can get buy-in potentially from stakeholders that you need to get buy-in from. So one important lesson was that with a complex code base, such as the one we were working in, we couldn't just plug and play with our components. I think the client assumed that we could do this, and we really couldn't. So there are some trade-offs working in a monorepo in isolation from the main app. One of them is that developers will continue to update and iterate on the main app as time goes on. Components will be updated. designs will be out of date really quickly. And, sometimes those things don't get communicated to you soon enough. And so, we've built this shiny new component, we released the package, we've imported it into the app. All of a sudden there are new changes and we have to go back and we have to fix those things or update those things, and we have to schedule another release. That's all part of the process, and that's what we do as developers. So that's all normal to us. But like I said, there's a time trade-off here, and it's kind of crazy when you think about it, that Brian, Sung, and I were, at the end of our time on this project, the only two front-end developers working in this Monorepo and importing components into the main app. And so we were doing like this large-scale enterprise sort of design system, and it was just the two of us. So it was very challenging, but I guess rewarding in terms of the lessons that I took from it. Let's see, like I said already, implementing new components in this design or from the design system and deprecating old ones proved to be very challenging. Sometimes it could take weeks to implement a single component or to switch out a new one for an existing one in the app. And it would be nice to have the time. I don't know if clients will allow you to do this to really refine your design system before you start using it in any apps, and to really plan out, how long it's going to take to switch those things over, because it's not just a simple, like, we can do this in a day or two. Styles were another pain point for us. The main app had component styles as well as global styles. It also used style components. Our elemental design system was styled with SCSS modules, so we actually spent a lot of time converting things from style components into SCSS, just so that they could be the same and there was a single way of doing styles in the app. Because each component was being imported as a separate package, much like with the component itself, you can't really make style changes on the fly. So for people who want to see immediate changes on the front end in the app for stakeholders, we found ourselves using a class names prop a lot and then just overriding the styles in the package while we were waiting for a new release. So this is another concern. It can get kind of hairy when you've got styles happening in the main app, but you're also pushing for everyone to use the styles in your Monorepo as the single source of truth, because those were approved by designers and all of that, and you want to get away from trying to use override styles. But in practice, this it's not an ideal world, and sometimes you have to use a class names prop. Like I said, the biggest takeaway from this is to plan for a month-long scope when you're implementing a new design system, especially in a complex code base across multiple apps at an enterprise level. It can take an entire team and it can take months, a year even. And we didn't have that luxury. And so we made do with what we had. It was definitely a learning experience for sure. And I'm glad that I had it, because now I know about multi-package monorepos, and I can tell you all about them and the pros and the cons and the scary parts and stuff to beware of. All right, so here are some resources for you to check out if you're not familiar with these things already. Storybook.js.org. yarnpackage.com, learna.js.org, rollupjs.org, and atomicdesign.bradfrost.com. So I think that covers everything that I talked about here today. And yeah, feel free to Google more. There's lots of online tutorials that you can do about like using Learna and Yarn and in a monorepo. This sort of just scratched the surface. It was meant to introduce you to the concepts. If you are already aware of all of this and are a complete expert, I'd love to chat with you, and we can trade war stories about it. All right, that's my talk on monorepos and managing dependencies in a front-end design system. Thanks for listening, everyone.